Welcome back to Boiler Wild. This is episode 33. I am just by myself today. I think when this one comes out, you will have had 3 guests onto this podcast, and that is something I'm super excited about, having guests on, learning from people. Had Chris Dasher on the first one, I believe episode 30. 31 is Ray Wolfarth. He is an author of many, many boiler books. He's out of Pittsburgh, and he has tons of knowledge and experience on the heating side of boilers. And then you have Jim Burgess with Chicago Water Treaters. Him and his brother are operating a water treatment company out of Chicago, and all 3 of them had great things to say. I really enjoyed the conversation of them, so I appreciate them coming on. But today, just a couple of housekeeping items I wanted to talk about. But October 13th to the 16th, I am hosting a online electrical workshop. This workshop will help you troubleshoot better in the boiler room. You can find more information on the Boiler Room website about it under the Learning Center. You'll see information. You can DM me on LinkedIn, email me, whatever. It's going to be a really great workshop. We have 5 performance objectives. You're guaranteed to learn all 5. Someone else is also helping teach the workshop. They are very experienced in electrical, way more experienced than I am. So it's going to be him and I. We are bringing a 1-2 punch for this online electrical workshop. You don't have to travel. It's online. It is in the evening, so you don't have to miss work. I've had companies reach out. Hey, we'd love to sign up, but our people are busy that day. Well, it's in the evening, so there's no excuse other than you want to watch football or something, but you have to make the time. If you don't make the time, you will never learn anything. There's never going to be a convenient time to learn something new. There's always going to be a better time to do something. So that's my plug for that. Sign up soon. Over 50% full. Only have 20 spots available total, and about 50% of those are gone. So what I want to talk today is a LinkedIn post I made probably a week ago about jumping out boiler safeties. And, social media has this art to it. If you write very straightforward and tell the truth right up front, you don't get engagement. And, there is this like shock and awe factor for engagement. I don't really do that, but this post is a creative post. I wrote it's in reference to a blog I wrote that you can read on the Boiler and website. And it's basically when you're allowed to jump out boiler safeties. And the comments didn't disappoint. I can tell who clicked on the link to the blog and who didn't. And basically it was just a teaser in the post that said, hey, if you want to learn more, click on this link. And, I don't blame people not clicking on the link. A lot of people don't want to get off the app. A lot of people get on LinkedIn just to mindlessly scroll and waste time. That's fine. There's, most people just don't want to go read a blog, even though the blog is pretty short. But I just wanted to clear things up. And as most of the comments, I could tell, didn't actually read the blog posts, and they all accuse me of making things unsafe, and you should never jump out safeties on a boiler, and all this other stuff. And I 100% agree. The whole blog post is basically setting up when you should jump out safeties, and then I tell you it's never okay, because you will eventually run into a situation where you either harm yourself, harm the equipment, or harm others. And that's not a if, that's a when. And I am very firm on this. I don't know what it is about boilers. I guess it's all safety things. And if you are up in an elevated position without like handrails and you're not tied off and you do that for 10 years, you're gonna, and it doesn't even take 10 years, but you do that for 10 years, you get complacent and you think, oh, well, I don't fall, other people fall. Well, all it takes is one slip, one trip, and you fall. Like, just because it hasn't happened before doesn't mean it won't happen. And actually, because you've gone so long without an accident, you are more likely to have an accident because you get complacent. And you have to be really careful when walking around or when working with boilers that you do not get complacent. Complacency kills, but with boilers, it mostly just causes accidents. Everybody jumps to the boiler explosion thing. The amount of boiler explosions that happen, it's pretty rare in the United States, but there's probably a lot of near misses. I know there's a lot of near misses that never make the news because nothing really happened, but it ends up being a very expensive repair. It gets repaired really quick, and the company shoves it down and nobody talks about it. And that's more common than people think. The boiler explosion, like, it takes, you have two sides of the explosion. You have to heat up a bunch of metal red hot and then add water to it, which is a lot of, you have to have the low water cutoff fail, and then you have to heat up all that metal, and then you have to add water to it. So that takes a certain amount of things to happen in order for that to occur. And most boilers will just, the low water cutoff will fail, which normally is tied to the pump control. So the pump just never even kicks on, and it'll just melt the boiler or overheat the boiler, or somebody catches it before it gets crazy. And then the other one would be a furnace explosion. This is probably it's definitely more common than the water side explosion, but it's probably normally not as big as most people make it. As far as, like, you might get a huff or a woof, very few of them are like blowing the doors off and sides off of boilers and causing severe damage. I've heard of like condensing boilers split their burner, the mesh burner. They split it, have a delayed ignition, blow the sides off the boiler. But beyond replacing the burner and putting the sides back on, nothing really happens. It does happen. Like, I'm not saying that gas sided or furnace side explosions are rare or not dangerous by any means, but they are more a common occurrence than a water side explosion. But even then, both of those explosions, that's rare compared to just near misses and complacency. And where this is really prevalent is plants with maintenance people who work on boilers without proper training. And proper training is not, I went to a 2-day class, so now I'm certified to work on the boiler. No, that's proper training takes months of structured training, but it takes a environment in which you operate that the training is reinforced. If your manager just tells you, go figure it out, and you can just do whatever you want to the boiler, and there's nobody there to guide you or help you, and management doesn't have respect for the boiler system, then that's not training, that's not education, that's just, one, you're getting a certificate that doesn't mean anything. If you do a 2 or 3 day boiler class, like, that's not going to get you, that is enough time to get you slightly educated about a few things on the boiler side, but it should basically get you educated enough that you realize you don't know anything about boilers. And it's fine to not know anything about boilers and to operate it, but it's when you start troubleshooting or trying to fix problems yourself, that's where you run into issues. And then if you start, moving wires or constantly replacing parts, you don't know what you're doing, and you can get away with it a lot of the times, and that gets into a culture of, we don't need boiler training, or we don't need, boiler safety and all this stuff. And there's plenty of people that have jumped out boiler safeties and nothing happens. Well, if you don't have a negative consequence to an action, that action is reinforced as positive, even though the person may know that it is not great to jump out safeties. They also may not even know that it's not acceptable to jump out safety controls. Some people will jump out a safety control on an air compressor and not think about it. And they may see other people jump out a safety control on a boiler and not think any about it. And if you don't work in an environment where anyone knows any better, and that's the only thing you've taught and that's the only thing you've seen, how are you actually supposed to know that jumping out boiler safety controls is not safe and that you should know better? Like, there's this sentiment from people in the boiler industry that everybody should just know better and operate from a position of knowledge, where most people, like, the amount of knowledge that is working on boilers and working around boilers is very, very low. And the people that are saying, oh, everybody knows that, or they say, oh, like, that's easy stuff, we don't need to teach that. Those are the people that are probably in the top 10% of knowledge, and they don't realize how little knowledge people actually have. Even if you do work for a boiler company, like a service company, an HVAC service company, imagine this: you work for an HVAC service company, you've worked on rooftops for 3 or 4 years, and all of a sudden one of your new accounts has a boiler in it, and your company just sells a whole building maintenance plan, and they're like, just PM the boiler, just figure out what you need, and PM it, and figure it out and fix the problems. How are you supposed to know as a general HVAC person about a boiler? That's when you go, well, I don't know anything about a boiler. But then your company is telling you to do preventative maintenance on it, and normally that ends up being, you just kind of stare at it, and if you don't really know what you're doing, not touching it is almost the best case scenario. The problem is the company bills it as preventative maintenance was done. If it is like a steam boiler where it has to get taken apart, a lot of times companies will take it apart, get it inspected, it passes inspection, they close it up with new gaskets, and then they don't check combustion, or they don't know how to make adjustments on combustion if it's like linkage. So good enough combustion is good enough for them, and then they don't really know how to properly check the safety controls and like what to look for with issues, and even operation of the boiler, of, hey, the boiler is turning on and off, and how do we sequence it with these other boilers? All this stuff is generally pretty low level knowledge, but you can't assume that people know this knowledge. Like, you have to learn it. And if this HVAC person or whoever doesn't have somebody to call, doesn't have an expert to call, and they're just told to go figure it out, then they're just searching on the internet, and it just leads to a bunch of misinformation. And as they learn more about the boiler, they essentially learn that they don't know as much about a boiler as they thought they do. And that's how safety controls get jumped out. So for the record, never jump out of safety control. There is never really a good reason to jump out of safety control. You can do it temporarily if you are a technician and you know what you're doing. And I say temporarily as in you are there fixing a problem. This is not, oh, we are going to jump it out for hours till we get a new part or something. No, that's nonsense. Yeah. Shut down the boiler and you do things safely. If somebody else wants to tell you to do that, or if somebody else wants to do it, get it in writing. As the blog post said, if something happens, if you are inside, the company HR will just say, well, you violated our safety protocols. They have binders and binders and binders of safety protocols, and there's probably something in there that says you can't jump out safety controls. It's all legalese for safety to protect the company. So they'll just hit you with that and say, oh, you broke these. And, as much as you want to say, well, a manager told me to do this or whatever, even if they admit to doing that, then HR will also say, well, this manager also violated our safety protocols and was fired and whatnot. But it ends up being a bad situation. Now, if you are a service person or like an operator and you find a safety control jumped out, you obviously want to find out why it's jumped out, and you have to, either get a new control device or you have to shut down the boiler for an extended period of time, whatever you have to do. But just understand that nobody goes into work expecting to have an accident that day. And nobody says, you know what, I'm going to cause damage to this equipment. Everybody operates, you get in your car and you say, hey, I got to drive to work today. You never say, I'm going to drive to work and have an accident today. That's ridiculous. Things just happen. That's how the world works. You're just wrong location, wrong time. Same thing with boilers. When you bypass safety systems, when you don't check that safety systems work, you are under the assumption that everything's working and everything's going to be okay. And that is a bold assumption to make. However, people get away with that because typically, if you assume it's working or it's going to be okay, it will be until it's not. Like, if every time somebody jumped out of safety control, the boiler stopped working, or there was damage, or they got fired, then people would have a very negative response to jumping out safety controls, and then they wouldn't do it. And I like to look at other industries for this, and a lot of even in the boiler world, a lot of manufacturing facilities will have like cardinal rules, like lockout, tagout, and confined spaces are like cardinal rules. If you're found violating them, you're immediately fired, walked off the property. Just no tolerance. In civil construction, digging like a trench, anything over like 5 feet or whatever needs shoring or like proper sloping. And if you have uninformed workers just jumping in trenches and not understanding the dangers of trench collapses, or they climb out of the trench and they remove the shoring, and then they look down and say, oh, like we forgot to open that valve. And instead of spending 15 minutes to put the shoring back in, a worker says, oh, I'll just jump down there and just open that valve real quick and then jump out. They think that is the right thing to do, and they also assume that the trench won't collapse. And I used to work with a guy who would tell customers, and he would say, like, well, the customers would ask like, well, why did this part go bad? Or how can you tell like when this part's going to go bad? And he would always ask them, how can you tell when a light bulb's going to go bad? Like, it's fine one time you turn it on and it's not fine the next time you turn it on. Same thing with trench collapses. Just because you remove the shoring and just because you're only going to be in the trench for 2 minutes, not even, to turn on a valve doesn't mean the dirt knows like, oh, they're just going to be real quick. They were safe before, but it's only 2 minutes. I'm not going to collapse now. There's a pretty famous video of Oregon OSHA showing up to a trench, and a guy is in the trench, and they say, hey, you can't be down there and all this stuff. And the guy starts coming out and they say, oh, like, well, we're installing the shoring, but he was like in the trench while installing the shoring, and the trench collapses right when Oregon OSHA's there. It's all on video. Nobody got hurt, but the guy had to like jump up on the trench box, and they scrambled to get him out of the trench. But it's just a good reminder that accidents and bad things happen no matter what the circumstances are and no matter what your intentions are. And that's why your intentions always have to be pure, and you have to remain calibrated on what you think is safe and what your procedures are for safe operation around boilers, how you operate around boilers. If you approach every situation like everything's going to be okay, and another good example is bubble checking gas valves on a gas train on a boiler for like a natural gas train. If you approach that as, oh, well, the last 50 valves I've checked, I bubble checked, didn't have a leak, so these aren't going to have a leak either, but I just need to go through the motions just to check it off the box. If you approach the job that way, one, you're probably going to make mistakes, but two, you're more prone to get further away from your calibration of what is acceptable and what is correct. You should always approach a situation like, bubble checking the seats of valves as, hey, these two valves are bad and they leak by until I prove that they don't leak. And when you reframe your mindset like that, you have to prove to yourself that the valves don't leak. Otherwise, they're bad. So how are you going to do that? And you go through your whole leak check procedure and you go, all right, these are good. I've proven to myself that they don't leak, and I have properly done the leak checks for these valves. Same thing with safety devices. Oh, I'm checking safety devices on a boiler. Oh, low water cutoff. I'm going to do an evaporation test. I'm not going to just blow it down. I'm going to check the low gas, going to check the high gas. I'm going to check the set points, make sure the set points are within range of what they need to be. I'm going to check the air switch, going to check all the limit switches, draft switch, everything. And you're not going to skip any of the safeties. You're not going to skip any part of the boiler because you assume none of them work until you actually see for yourself and prove to yourself that they do work. And when you approach every situation like that, and it's hard to do that, some days I understand, like it's Friday after a long week and it's 1 p.m. and you're checking safety controls on a boiler, and it's a smaller boiler. Say it's 100 horsepower fire tube, easy boiler. It has a Honeywell 7800. It's got a linkage burner. Everything looks fine on it. And it's in a small facility, maybe a small manufacturing facility or a school or something. No big deal, no pressure. Nobody's in the boiler room. Maybe your contact, you saw him in the morning, but nobody else has stopped by. Nobody's making you test all the safeties. Nobody's making you prove that the boiler is in great condition on an operating standpoint. And you have your checklist, in your hand, and you can check off 3 safeties in 10 seconds. 1, 2, 3. doesn't even take 10 seconds. And whereas it may take 5 to 10 minutes to check those 3 safeties. When's the last time an air switch hasn't worked? I've tested tons of these and they always seem to work. So, this one seems fine. It's fine. Or even worse is when you do check a safety and it doesn't work, but then you second guess yourself and say, if this safety doesn't work, then I'm going to have to, shut down this boiler or write this up and get this replaced, and that's going to add time to the day or, cost to the customer and stuff. I must have just checked it wrong. So I'm sure it works. I wasn't really sure about how to check the safety, and I must be doing something wrong. It probably works. So then you just check it off. I've seen that done, and that's not a good habit to get into either. If you operate from it doesn't work and you have to prove to yourself that it works, even if you are checking it wrong and the safety does work, that's a learning situation for you on how to check a safety control and how maybe, this safety control operates. And you have to check it and prove to yourself that it works. You should call somebody. If you don't have somebody to call, that's probably my number one thing that helps me when I was learning boilers, is having an expert to call. And I can't even imagine what it'd be like working in a company when nobody can help you that's competent with boilers. And there's tons of companies with tons of competent people in them, but I've also seen like general HVAC companies where nobody really knows boilers, but the company is selling boilers. The salesperson that sells a boiler contract or boiler service knows nothing other than, they look up the model number of the boilers and then they reach out to another company to get all the gaskets or whatever that they need. And then they just hand them to you and say, go figure it out. We sold this service. That is very frustrating, very lonely as a person to try to figure out stuff. And a very motivated person will figure it out. They'll search on the internet. They will learn and they'll figure it out. But if you only work on boilers every so often and it's not an everyday occurrence, you're going to struggle. And I don't know how anybody is going to be working on all the equipment. If you say, I'm going to learn all equipment, no, you're not. You're never going to get good at anything. And in 2025, everything is so complicated. Every manufacturer has its own custom board, PLC, custom touchscreen. Even in the boiler world, I only work with boilers. I only see boilers, teach boilers, and I still feel like I know nothing. How am I going to learn all the rooftops and all the makeup air handlers and all the chillers and then, all the specialized HVAC equipment and all those systems, VRF, CO2, refrigeration. Like the industry is huge, and expecting a technician to just be able to fix everything is the craziest thing I've ever heard. And it's also, you got to have the right tools. Like if you work on refrigeration systems, you got to have all the refrigerant and you got to have, the scales and the gauges. And then to work on boilers, you got to have all the manometers and the, pipe wrenches, larger wrenches, combustion analyzer. Like there's specialty tools for every single thing. And expect somebody to have all those in their truck and to just pull out this knowledge randomly when they are working with equipment. Yes, if you sit down and read the manual of a piece of equipment and understand the basics of electrical troubleshooting, you can figure something out. But that is not efficient for your customer, and it is not efficient for your company. So, and I mean, it's unrealistic in 2025 to be able to train people on everything. If you have a BMW tech and they are specialized in BMW cars, they get really good at BMW cars. Then you bring in a Ford. Yeah, they may know their way around, but Ford has different computers. They have different engine diagnostics codes and all this stuff, and they're going to have to stumble through it, and they're not going to be proficient, and they're going to struggle. And then bring in all the other manufacturers. And then, oh, by the way, you're going to have to work on tractors too, and then semis and heavy trucks, dump trucks. that's the same thing with telling somebody they're going to have to work on all things in HVAC. You're an everything tech. Oh, I work on everything. There's no pride in saying that you work on everything. Anyways, that is a rant. Going back to safety controls, clear the air. It is never okay to jump out of safety control. I believe that we, even as a boiler industry, don't hold safety in the boiler room to the standard that it needs to be. There's a certain amount of respect that you have to have for boilers and for the energy, and everybody talks about it, but actions speak louder than words. And I've seen some sketchy stuff done by some supposedly reputable contractors and companies and operators around boilers that I would never think is possible or imaginable, but it happens. And that waters down what other people think about boilers and safety, and it becomes okay to jump out safety controls and anybody can work on a boiler and all this stuff. Like there's a whole laundry list there for maybe another podcast. But if you are listening to this, 2 key takeaways. 1, it's never okay to jump out safety controls on a boiler, and it's never okay to change the operation of a boiler beyond what the manufacturer wants. Very, very rarely or very few times do you know better than the manufacturer. And I say that's very few times. I can think maybe less than 10 times where I knew better than the manufacturer, but when you call them up, it was, maybe a common problem that they were seeing and they were coming out with a fix. So it's not that they didn't know about it. Every manufacturer tries their best to make a good product, but stuff gets through, especially, with boilers that's pretty low volume. They don't always get the feedback that they need on products. So when there's issues, sometimes, you're the one to solve it, but they're aware of the issue. And then the second takeaway is you always have to be careful of what you think is normal and what your calibration is. Your calibration for safety has to remain as true as possible. And when you walk into the boiler room, first thing you should do when you walk into a boiler room, whether it's a steam system or hydronic, or any mechanical room, is make sure that you are operating in a safe environment and your safety and other people's safety comes first. If you have steam boilers, look at the water level and you ensure that the water level is true in the boilers. You make sure that you don't have serious combustion noise. You make sure that you don't have black smoke coming out of the stacks. You make sure that you don't have any exposed wiring that it looks like somebody was jumping out safety controls or inside junction boxes. You make sure that you don't have water dripping on equipment, water dripping on electrical panels. You make sure that the boiler system looks like it's operating normally, that somebody hasn't added something or taken something out of the system that would make it unsafe. And then you operate from the stance of, all right, my duty today is to work on this boiler and figure out what is wrong with this boiler. And when I do this, I need to make sure that I am being aware of everything else in the boiler system that is on that particular boiler and making sure that it works. So, you may find that a low gas pressure switch doesn't work and, gas pressure was fine and you have to change the switch. Well, it doesn't take more than 30 minutes to go through the rest of the safety controls on the boiler. And it all depends on how large the boiler is. At a very minimum, you should check the low water cutoff and maybe the secondary low water cutoff. You should look at the wiring. You should look for any problems. You want to be proactive with looking at problems, but your calibration is, this boiler is not safe until I prove to myself that it's safe. And when you think from that mindset, you look at things differently. If you walk in there and say, the boiler's fine, I'm just going to change this low gas pressure switch, wire it up. Yep, boiler runs. Yep, flame. All right, we're good. Sign here. If you operate that way, you'll leave tools behind, you'll make mistakes, you'll leave covers off, you'll do all kinds of dumb stuff. You'll leave the manual auto switch in manual, and the customer will call you or call your supervisor and say, hey, the boiler's running, but it's not making steam pressure. And then you'll drive all the way back to that job, and then you'll flip it to auto, and all of a sudden you're going to get home on time on Friday, and now you're getting home 2 hours late because you couldn't spend an extra 20 seconds to make sure that all the switches were in the proper position and to make sure that you were checking out of the boiler room because you weren't following your process. So that's my 2 takeaways. Please, 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 boiler safety. Always remember, it is very important. Just because nothing negative happens to you now doesn't mean it won't happen into the future. And you are dealing with equipment, with parts, with materials that do not know you're human and that will hurt you, cost you lots of money, and kill you, injure, whatever. Just maintain your calibration, never jump out safety controls. Always assume it doesn't work until you prove it works. Thank you for listening to this episode of Boiler Wild, episode 33, I believe. I don't know, I'm losing my mind here. 33. And we are going to have more episodes. We are loving this podcast. I love having guests on. I have a couple more guests lined up, trying to bring more and more people onto the podcast. I appreciate you. If you've listened this far, if you could rate the podcast 5 stars, that'd be great. If you have questions, you can DM me on LinkedIn or email me, Eric.Johnson@boilearn.com, BOILEARN. I appreciate you. Thank you for listening, and stay wild.